तो आज जो है हम लीड कोड का 4 सवाल जो है पिक किए हैं। हार्ड सवाल 4 पिक किए हैं, एक ग्राफ से, एक जो है ग्रेडी से, एक डीपी से और एक मैथ सेक्शन से। 4 हार्ड सवाल हमने पिक किया है। वन बाय वन हम जो है सभी को सॉल्व करने का ट्राई करेंगे। तो लेट्स स्टार्ट फ्रॉम द फर्स्ट क्वेश्चन वी हैव। फर्स्ट क्वेश्चन वी हैव मिनिमम ऑब्स्टेकल रिमूवल to reach corner. The first question I have taken, this question belongs to graph section of the lead code. So minimum obstacle removal to reach corner. So let's read the problem statement we have. You are given a 0 index 2D integer array grid of size m cross n. Each cell has one of two values. 0 represents an empty cell, 1 represents an obstacle that may be removed. So basically you have given an 2D integer array grid of size m cross n. Each cell has one of two values. So in each cell of grid there can be two values, either 0 or 1. 0 represents that the cell is empty and 1 represents that the obstacle that may be removed, and 1 represents that there is an obstacle in that cell which can be removed. So you can move up, down, left, right. So you can basically from a cell you can move in 4 direction. You can go upward, upper cell, you can go to the down cell, you can go to the leftward cell and the rightward cell. So you can basically move in 4 direction from one of the cell you are currently on. So return the minimum number of obstacle to remove. So you can move from the upper left corner to the lower right corner. So basically we want to move from 0, 0 to m minus 1, n minus 1, that is upper left to lower right. So minimum number of obstacle we have to remove so that we can do this task. So what is the minimum number of obstacle that we can remove so that we can do this task? This is the question we have. Now let's talk about the constraint we have. So number of cells in the grid will not be greater than 10 to the power 5, but it will be less than equal to 10 to the power 5. So what we can think of? What we can think of in this question? I am just opening the whiteboard. What we can think in this question? Basically we have a grid. We have a grid given in the question, and cell of each grid is represented by one of two values, either 0 or 1. Okay, so we have given a grid. And we want to start from this point and want to reach at this point. So this is basically destination and this is basically source. So we want to reach from this point to this point, and while reaching we are thinking of that there is some obstacle at some cell. There is one is present. So we want that we should remove the minimum number of cell and reach at this point. So let's see the question little deeper. So let's say if you call every cell is a like node in the graph. So it can be viewed as a graph. This this grid can be viewed as a graph, let's say, and each cell is a node. So this is a node. So basically each cell is a node. You can see clearly each cell is a node. Okay, each cell is a node. Very simple. Each cell is a node of the graph. So tell me one thing, that how many at most edge can be? So you can see the at most edge can be from any node is 4. So any node can have at max 4 edge, because it can, from this node you can only go leftward, rightward, upward, downward. So there can be only 4 direction. That's why there can be only 4 edge from any edge. So any edge of the graph, any node of the graph will only consist of at max 4 edge. Very simple. This is the one thing we have. So okay, very good. So if we make this graph, so this graph will number of edge is equal to n into 4, that is 10 to the power 5 into 4. At max the number of edge can be this much. Now we want that we can basically uh, so this is the basic thing we have now. So we talked about the number of edges and nodes like that. Now think about the solution, that how I can proceed in this solution. So everyone think of DFS first. uh, is DFS here going to work or not? Is DFS here going to work or not? Okay, it's a very obvious question that everyone should think of, that can we use DFS here? Then we should also think of, can we use BFS here? And if we use DFS and we can't do it using DFS, then what is the problem because of which I am unable to do it using DFS? And same goes for BFS. Then that how that problem can be eliminated, we can think of, and in this way we will come with some optimization in our DFS or BFS. If not possible, then to remove that problem, there can be other algorithm which can work here. So we will think like that. So let's think about DFS. That someone says that I will start from this source node and do DFS. Okay, he will do DFS, and while doing DFS, this is a node, let's say S. He will go somewhere, he will go somewhere, he will go somewhere, he will go somewhere, somewhere, like this, and at finally he will reach the point destination. And in the path, the number of cell having value 1, he will go through. He will count that path is equal to, let's say, x. Matlab, he will count that number of cells having value 1 in this path, and he will tell that this is going to be your answer. But there is a problem. Problem is very simple. So we should think one thing I am telling you. So if you are going to write the solution like likewise we have talked about previously, that we will do DFS and likewise we will move, and we will find the count of the number of cells having value 1. So we will start from here. So basically in the graph it is told that, so one more thing, that if you have a graph and you are going to write a solution like this, and in that graph, let's say there is a cycle. If cycle is present in the graph now, then if you will write that solution, you will start DFS and write that solution, then what will happen? Basically you want to go like this. So if there is a cycle, it will so basically we are thinking of a DP solution. If you are talking about that you will do DFS, so likewise you will move. So you can't, I am telling one more thing. Okay, I was telling a very obvious question, that let's say you have a tree. Let's say you have a tree. If you have a tree and you want to start moving from here and go to this point and go to this point and go to this point, so you want to explore every path, that you can start from here, either you can start from here, either 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 from here. So basically, let's say if you have a question of based on the tree, let's say you have a question based on the tree and you want to find something, and you want to find something. Okay, you want to find something you want to find, and for that you have a question like that. If you start from here, you make this node as a root, the answer can be something. If you make this node as a root, and the answer is something. If you make this this node as a root, the answer is something. If you are making this node as a root, the answer is something else. If you are making this one, answer is something. If you are making this one, answer is something. So if you change the root, answer will change. So they are asking you to find that tell me if tell me what is the maximum value of that answer for any root. In that case, you can call DFS in this tree from any vertex v as a root, for each vertex v as a root, and you can simply find that find the solution of that algorithm. And let's say it is given in the question that no node has more than 2 edges. In that case, you simply write a solution of DFS of v comma free for each node. For each node you will write a solution of DFS of v comma free, that which is the prior node, then from which node you have reached this node. So basically v comma pre is that you have reached at v node from pre node. So you write this type of function and you memorize that type of this function, and basically you call from each node. So you are going to memorize that memorize that DFS function, and you will get the solution, because from any node you can reach from only 2 node. So number of transition will be 10 to the power 5 into 2. So it's acceptable. This type of solution you use to write in that case. But if we talk about this problem, it has cycle. So if I slightly modify this question like this, so you can't memorize that. You will memorize that, but it is not going to work, because what will happen? First you will calculate the value of this node, then you will store, and again if they are asking you to find, you will get that. But what will happen? It will go here to here to here, here, and here. So it doesn't calculate this value. It started from this node and it doesn't calculate the value for this node. If he calculates, then he will store, but he haven't calculated yet the value of this node and reached again at this node. So what will happen? Due to this problem, you can't memorize this solution. So if you are going to write that dp of v comma pre is not equal to -1, return that value. So it hasn't calculated, and again he has reached at this node. So you can't write the solution like that. So here is the same problem. Here is cycle like things. It is not like tree. It is not like tree. So you can't write the solution like this. But if I says that let's slightly modify the question, that you can only move rightward and you can only move downward, then this graph will not remain graph. It will become tree. You can simply see it will become tree. It will simply become a tree, and not a tree. It's a directed graph, you can say. Directed tree, not undirected tree, directed tree. And you can, in that case, you can simply write a DP solution. You can simply write a DP solution. What will be the, you will say that number of nodes having value 1. You want to find a path. You want to find a path such that number of nodes having value 1 in that path should be minimum. So for that, if dp of ij you want to calculate, that is number of nodes in the path from I comma j to node m-1 comma n-1, so that the value present at in the path value 1 is present in the path should be minimum. So that, what is that value? So first this I comma j cell will have 0 or 1. If it has 1, so if it has 0, then its value will be 0. Right. If it is 1, then its value will be 1, plus minimum of, you can either go from this node to dp of I plus 1j, or dp of I j plus 1. So simple, the transition will be like that. But we want to little think that can we consider it as a, if we consider this problem using this model, uh, will answer affect or not affect? I want to think that. Okay, I want to think that if we consider this problem, अगर मैं इस सवाल को इस तरीक़ा से देखूँ, इस डीपी सवाल की तरह देखूँ, तो क्या इससे आंसर इफेक्ट होगा कि नहीं होगा, ये मैं सोच रहा हूँ। ये मैं सोच रहा हूँ कि क्या मैं इसको डीपी वाला ये सॉल्यूशन लिख सकता हूँ, इसमें ये काम करेगा कि नहीं करेगा, यही मैं सोच रहा हूँ। और नहीं करेगा तो अगर करेगा, कर सकता है कि नहीं कर सकता। तो इसमें कोई भी पाथ इस तरह का फॉलो होगा। तो ये सॉल्यूशन काम नहीं करेगा। इसका मैं एक टेस्ट केस आपको देता हूँ। आप अगर इस तरह का सॉल्यूशन लिखोगे ना तो ये बिल्कुल नहीं काम करने वाला है। इसका मैं एक टेस्ट केस देता हूँ। देखिए इसमें क्या है ना, आप ऐसे जाइएगा, ऐसे जाइएगा, ऐसे जाइएगा, ऐसे जाइएगा, तो ये मिनिमम आएगा। ऐसे चलने पे आपको जो है मिनिमम कॉस्ट आने वाला है, मिनिमम नंबर ऑफ ऑब्स्टेकल आने वाला है। आप सोचिए ना, आप फिर से लेफ्ट वार्ड चल रहे हैं तो आपको लेफ्ट वार्ड चलने पर भी मिनिमम मिल रहा है और अपवार्ड चलने पर भी मिनिमम मिल सकता है। तो आप इस तरीक़ा से इस सवाल को देख रहे हैं, इसीलिए वो सॉल्यूशन तो नहीं लिख सकते यहाँ पे। यहाँ पर चारों डायरेक्शन को हमको कंसीडर करके चलना पड़ेगा। हाँ। तो अब इस तरह से डीएफएस चलाना आसान होगा। तो एक सॉल्यूशन तो है डीएफएस में, ये है कि जहाँ पर चले गए हैं वहाँ नहीं जाना है। हाँ, लेकिन वो सॉल्यूशन एन स्क्वायर का होगा। एन स्क्वायर का क्या, बहुत का हो जाएगा सॉल्यूशन। मतलब एन की पावर 2 की पावर, मतलब हर जगह से, हर नोड से 4 पाथ निकलता है और ऐसा ऐसा एन नोड है, 4 की पावर एन होगा उसका कम्प्लेक्सिटी। तो डीएफएस सॉल्यूशन लिखा जा सकता है लेकिन उसका कम्प्लेक्सिटी 4 की पावर एन होगा। समझ रहे ना, डीएफएस सॉल्यूशन लिखा जा सकता है लेकिन उसका कम्प्लेक्सिटी 4 की पावर एन होगा। सिंपल सा बात है, उसका कम्प्लेक्सिटी 4 की पावर एन होगा। तो वो डीएफएस सॉल्यूशन तो नहीं लिख सकते भाई। डीएफएस सॉल्यूशन लिख सकते हैं यहाँ पर, लेकिन उसका कम्प्लेक्सिटी 4 की पावर एन जाएगा। कुछ और लिखना पड़ेगा अपने को। वी हैव टू राइट समथिंग एल्स। तो कुछ और लिखना पड़ेगा अपने को। ठीक है, तो बीएफएस करने का कोई मतलब नहीं है, डीएफएस ही करना पड़ेगा क्योंकि सारा पाथ एक्सप्लोर करना चाहते हैं आप। तो बीएफएस कैसे कीजिएगा, तो डीएफएस का तो सॉल्यूशन है लेकिन उसका कम्प्लेक्सिटी है 4 की पावर एन। बीएफएस कैसे कीजिएगा, हाउ कैन वी डू बीएफएस? तो सबसे पहला बात कि शॉर्टेस्ट पाथ के पास, ये ज़रूरी नहीं है शॉर्टेस्ट पाथ हैज़ मिनिमम नंबर ऑफ ऑब्स्टेकल्स। ये ज़रूरी नहीं है जो पाथ शॉर्टेस्ट है उसके पास जो ऑब्स्टेकल का संख्या होगा वो मिनिमम नंबर होगा। इट्स नॉट नेसेसरी। पहली बात तो ये जरूरी नहीं है। और क्या है? और क्या है? तो बी एफ एस तो शॉर्टेस्ट पाथ से ही चलता है। तो बी एफ एस चला के आप कैसे निकालिएगा? जो बी एफ एस हमेशा शॉर्टेस्ट पाथ को ही चलता है, यही है क्रक्स। तो बी एफ एस का भी इतना बात हम नहीं कर सकते। और क्या कर सकते हैं? और क्या कर सकते हैं हम? हाँ, और क्या कर सकते हैं हम? और क्या कर सकते हैं कि हमको इस सवाल को और कैसे देखा जा सकता है? इस सवाल को ऐसे भी तो देख सकते हैं कि सोचिए ना, आप इस सवाल को ऐसे देख सकते हैं कि ये है ना सवाल, सवाल को आप ऐसे देख सकते हैं। वी कैन सी दिस प्रॉब्लम likewise we are I am going to tell। ये देखिए, हमने इस ग्राफ को इस तरह से बनाया, हमने एज जोड़ा इस ग्राफ में, ठीक है, एज जोड़ा, इस तरह से जोड़ दिया मैंने। ठीक है, ये ग्राफ है अपने पास। अब कलर मैं चेंज कर लेता हूँ। तो ये अपने पास ग्राफ है। अच्छा से बनाते हैं अपन ग्राफ को। तो ये ग्राफ का एज है अपने पास, मैं जो जोड़ रहा हूँ ये अभी एज है, ठीक है, ये ग्राफ का एज है। सवाल देखिए बहुत आसान हो जाएगा, अभी देखिए। ठीक है, और एज जोड़ते हैं अपन इस ग्राफ में। और एज जोड़ते हैं अपन इस ग्राफ में। ठीक है, और एज जोड़ते हैं अपन इस ग्राफ में। तो हमने ग्राफ में एज जोड़ा इस तरीका से। आप सोचिए, जिस जिस नोड पर 1 है उसको हम मान लेते हैं कि 1 यहाँ पे वैल्यू रखा हुआ है। जहाँ जहाँ पे 1 है वहाँ वहाँ पे 1, वहाँ वहाँ पे 0, जहाँ जहाँ पे 0 है। तो ये सोर्स हो गया, ये डेस्टिनेशन हो गया। सोर्स से आपको डेस्टिनेशन पे पहुंचना है ऐसा पाथ से, सच दैट उस पाथ में जो नोड हो, नोड पे रखा हुआ वैल्यू का समेशन मिनिमम हो, नोड पे रखा हुआ वैल्यू का समेशन मिनिमम हो। इस काम को डायजेक्ट्रा से तो आराम से किया जा सकता है, डायजेक्ट्रा से इसको आराम से कर सकते हैं। नहीं कर सकते? कर ही सकते हैं भाई। बहुत सारा तरीका होगा नोड 1 पर पहुंचने, इस किसी नोड V पर पहुंचने का, ठीक है, बहुत सारा तरीका होगा। हम S से शुरू करेंगे चलना, तो बहुत सारा तरीका होगा किसी नोड V पर पहुंचने का। एक तरीका में इसका वैल्यू 1 होगा, किसी तरीका में इसका वैल्यू 2 होगा, किसी तरीका में इसका वैल्यू V3 होगा। हाँ, तो हम किससे चलेंगे? हम उससे चलेंगे जिस पे इसका वैल्यू मिनिमम होगा, जैसे V बराबर 1, इससे चलेंगे हम, ठीक है। इस तरीका से हम चलेंगे, कोई दिक्कत नहीं है। हाँ, इसी तरीका से चलेंगे तो डायजेक्ट्रा आराम से लगा सकते हैं। डायजेक्ट्रा का ही ये सवाल हो गया, एकदम प्योर डायजेक्ट्रा है, समझे? प्योर डायजेक्ट्रा है, इट्स अ प्योर डायजेक्ट्रा क्वेश्चन कि आप सोर्स से डेस्टिनेशन पर जाना चाहते हैं, ऐसा पाथ से सच दैट नोड पे रखा हुआ वैल्यू मिनिमम हो, यही तो सवाल है। तो डायजेक्ट्रा अच्छा से डिजाइन करना है यहाँ पे, ताकि क्या है ना कि ठीक है, डायजेक्ट्रा अच्छा से लिखना है, ठीक है, डायजेक्ट्रा ही लगाना है, वेरी सिंपल। डायजेक्ट्रा में क्या क्या होता है? डायजेक्ट्रा में ये होता है कि आप सोर्स से चलना शुरू करेंगे, हाँ, तो सोर्स पे ऑब्स्टिकल हो भी सकता है, नहीं भी हो सकता है, हाँ। मान लीजिए आपका सोर्स क्या है? सोर्स है पेयर ऑफ इंट 0,0, हाँ, और उस पर रखा हुआ वैल्यू, वहाँ पर आपको पहुँचने में कितना कॉस्ट लगा, ठीक है, वही। तो यही बात है। तो आपने बोला कि मैं एक क्यू बनाता हूँ, और मिन हीप यूज़ करते हैं हम लोग, ठीक है, मिन हीप MNPQ, हम लोग मिन हीप यूज़ करते हैं डायजेक्ट्रा जब भी लगाते हैं। लोग सेट भी यूज़ करता है, मैं जो हूँ मिन हीप यूज़ करूँ। मिन हीप का डिफिनीशन अपने पास यहाँ है, MNPQ मैं रखा हुआ हूँ। हम लोग यहाँ पर जो है मिन हीप यूज़ करेंगे। मिन हीप हमने यूज़ किया, तो मिन हीप एक बना लेते हैं, MNPQ मिन हीप का डिफाइन किया गया है, एक क्यू बना लेते हैं, लेकिन इसमें इंट नहीं रखते हैं, ठीक है, इसमें एक्स रखते हैं, XY, इसमें भी रखते हैं XY, और इसमें भी रखते हैं XY। XY किसको कर देते हैं जानते हैं? मिन हीप में आप क्या क्या रखिएगा, वो सोचिए किस नोड पर आप हैं, उस नोड पर जिस रास्ता से आप आए हैं, उसका वैल्यू कितना है। तो हम हीप में तो वही रखेंगे, हीप में हम रखेंगे वैल्यू कॉमा I कॉमा J, यही ना। मैं बनाता हूँ टाइप डेफ पेयर ऑफ इंट कॉमा पेयर ऑफ इंट कॉमा इंट, ठीक है, और इसका नाम रखता हूँ XY, वेरी गुड। तो पेयर ऑफ इंट कॉमा इंट, तो क्यू में सबसे पहले क्या पुश करूँ? देखिए क्यू में मैं पुश करता हूँ, सबसे पहले 0,0 से हम चलना शुरू करेंगे। 0,0 पर क्या है वैल्यू इस ग्रिड में? अगर 1 होगा तो एक ऑब्स्टेकल तो आपको हटाना ही पड़ेगा, तो ग्रिड ऑफ 0,0 0,0 आपने डाला, ग्रिड ऑफ 0,0, फिर I फिर J, I J नहीं 0,0, क्योंकि 0,0 से शुरू कर रहे हैं, बहुत बढ़िया, इतना डाला आपने इसमें। अब डायजेक्ट्रा अपना शुरू होगा, कोई दिक्कत नहीं है, आवर डायजेक्ट्रा विल बी स्टार्टेड, ठीक है। लेकिन एक चीज़ और है, एक एक इंट m बनाइए ग्रिड डॉट साइज, और एक n बनाइए ग्रिड 0 डॉट साइज, ठीक है। और इतना करने के बाद क्या कीजिए, एक काम कीजिए, एक वेक्टर ऑफ इंट विजिटेड बनाइए, इसको डायरेक्ट ग्रिड के बराबर कर दीजिए। हाँ, ग्रिड के बराबर कर दीजिए, क्या दिक्कत है, कोई दिक्कत थोड़े है। ठीक है, एक चेंज एरे बना लेते हैं। ठीक है, इंट CHG 4x2 का बनाते हैं। जीरो कमा वन, एक बनाते हैं 1,0, एक बनाते हैं -1,0, एक बनाते हैं 0,-1। ठीक है, ये चेंज एरे आपने बनाया, चेंज बनाया, ये सारा चीज़ बना लिया। ठीक है, डायजेक्टर हम करना चाहते हैं, एक अच्छा कोड लिखना चाहते हैं ताकि ज़्यादा कम्प्लेक्स ना हो चीज़। बहुत बढ़िया। इतना करने के बाद क्या करें? हाँ हाँ, ग्रिड के बराबर नहीं, इसके हर जगह पे इंट मैक्स रखते हैं। ठीक है, हाँ, m कॉमा वेक्टर ऑफ इंट n कॉमा इंट मैक्स। अब सोचिए, आप जो है 0,0 पे चले गए और अब उस पर कहीं और से तो जा नहीं सकते आप। 0,0 पर कहीं और से जा सकते हैं क्या? नहीं जा सकते। सिंपल सा बात है, कहीं से आप नहीं जा सकते 0,0 पर, क्योंकि 0,0 से ही चीज़ शुरू हो रहा है। तो उस पर आप जाइएगा कहाँ से? वही तो स्टार्ट पॉइंट है। तो उस पर आप कितना मिनिमम ऑब्स्टेकल के साथ आ सकते हैं? ग्रिड ऑफ जीरो को 0,0 अगर वहाँ पर है तो एक के साथ, एक ग्रिड के साथ आपको जाना, वहाँ पर पहुँच सकते हैं। नहीं तो 0 ग्रिड के साथ। तो सीधा सा बात है कि विजिटेड ऑफ 0 इक्वल टू ग्रिड ऑफ 0 0। वेरी सिंपल। इतना काम हम कर देंगे। इतना काम करने के बाद हम क्या करेंगे? अपना डायजेक्टर को स्टार्ट करेंगे। वाइल इज नॉट क्यू डॉट एम्प्टी, जब तक क्यू खाली ना हो जाए। ठीक है, ऑटो IT बराबर क्यू डॉट टॉप, टॉप की चीज़ को निकाल रहे हैं क्यू में से और कर दे रहे हैं क्यू डॉट पॉप। ठीक है, अब देखिए आपके पास वैल्यू क्या होगा। जिस नोड पर आप पहुँचे हैं, IT में एक i, j रखा हुआ है, वहाँ पर आप पहुँचे कुछ वैल्यू के साथ। हाँ, कुछ वैल्यू के साथ आप पहुँचे, वेरी गुड। तो मान लेते हैं उसको हम VAL, तो वो क्या होगा? IT डॉट फर्स्ट ही तो होगा। इसी तरह से हमारा I क्या होगा? IT डॉट सेकेंड डॉट फर्स्ट। इसी तरह से हमारा J क्या होगा? IT डॉट सेकेंड डॉट सेकेंड। ठीक है, ये हमारा हो गया। I J वैल हमारे पास तीन चीज़ आ गया। वी हैव दीज 3 थिंग्स वी आर एट। अब हम आगे क्या कर सकते हैं? आगे हम कुछ नहीं करेंगे। आगे हम क्या कर सकते हैं? इस I J से कुछ कुछ जगह पे जा सकते हैं। ठीक है, तो हम एक लूप चलाते हैं, फॉर इंट i इक्वल टू 0 नहीं, IND इज इक्वल टू 0, IND लेस देन 4 और फिर IND प्लस प्लस। ऐसा करते हैं हम। और ऐसा करने के बाद क्या करते हैं? सोचिए, आप इस I से I, J से I1, J1 पे जा सकते हैं। I1 क्या होगा? I प्लस CHG IND 0 और J1 क्या होगा? J प्लस CHG IND 1। वेरी सिंपल, ये होगा I1 J1 आपका। अच्छा, अगर I1 J1 ग्रिड के बाहर लाई करेगा तब थोड़ी आप वहाँ पे जा सकते हैं। तो पहले तो चेक कीजिए, इफ़ I1 इज ग्रेटर देन इक्वल टू 0 एंड I1 इज लेस देन M। इसी तरह से एंड J1 इज ग्रेटर देन इक्वल टू 0 एंड J1 इज लेस देन N। अगर ये कंडीशन होल्ड होता है तो आप I1, J1 पे जा सकते हैं, अदरवाइज आप नहीं जा सकते। तो एक बार अगर आप I1 J1 पे जा सकते हैं, ठीक है, तो लेट्स सी आपको जाना चाहिए कि नहीं जाना चाहिए। फिर वो भी बात है कि आपको जाना चाहिए कि नहीं जाना चाहिए वहाँ पे। दैट्स द वन थिंग यू विल हैव। ये भी बात है कि आप वहाँ पर आपको जाना चाहिए कि नहीं जाना चाहिए। तो जाइएगा कब? जाइएगा तब जब आप उस पर गए होंगे किसी छोटा वैल्यू के साथ, तभी आप वहाँ पे जाइएगा। बहुत ही सिंपल सा बात है कि आप वहाँ पे तभी जाइएगा जब उससे छोटा वैल्यू के साथ, उससे बड़ा वैल्यू के साथ पहले गए होंगे। तो पहले आप गए थे किसी वैल्यू इंट वैल्यू1 के साथ, तो वो आपके विजिटेड ऑफ आई और i1 j1 में स्टोर्ड होगा, i1 j1 में स्टोर्ड होगा। तो अगर वैल्यू1 इज ग्रेटर देन वेल प्लस ग्रिड ऑफ i1 j1 है, ग्रिड ऑफ i1 j1 है, वैल्यू1 इज ग्रेटर देन ग्रिड ऑफ i1 j1, वेल प्लस ग्रिड i1 j1। इसका मतलब आप जिस पहले जो गए थे i1 j1 पे कुछ बड़ा वैल्यू के साथ गए थे, तो उससे छोटा कॉस्ट के साथ आप पहुंच पा रहे हैं, तो आपको जाना चाहिए यहाँ पे उससे छोटा वैल्यू के साथ। तो यू शुड डेफिनेटली गो। तो आप लिखिएगा ग्रिड ऑफ i1 j1 इज इक्वल टू प्लस इक्वल टू वैल, नहीं ये ग्रिड नहीं, विजिटेड ऑफ i1 j1, विजिटेड ऑफ i1 j1 इज इक्वल टू वेल प्लस ग्रिड ऑफ i1 j1। आप ऐसा लिखिएगा, ठीक है। वेरी सिंपल थिंग वी कैन डू कि हम जो है i1 j1 से पे जा सकते हैं और कितना कॉस्ट के जाएंगे, कितना कॉस्ट के साथ जाएंगे, विजिटेड ऑफ i1 j1 के साथ। तो सिंपल सा बात है कि आपको इसी समय जो है पुश कर देना चाहिए क्यू में, क्यू डॉट पुश वेल प्लस ग्रिड ऑफ i1 j1 ओके, कॉमा i1 कॉमा j1 पुश कर दीजिएगा, ठीक है। और क्या कीजिएगा, और कुछ नहीं यार, तो गया। हाँ चलिए आप पुश कीजिएगा, ठीक है, कोई दिक्कत नहीं, वी कैन पुश लाइक दैट। अच्छा यहाँ पर देखते हैं, हाँ ये भी ठीक है, ठीक है। i1 इज ग्रेटर देन इक्वल टू 0, i1 इज लेस देन m, j1 इज ग्रेटर देन इक्वल टू 0, j1 इज लेस देन n। ये देखिए एन डी, तो ये इतना तो हो गया अपना, लेकिन एक चीज़ और यहाँ पे लिख देते हैं, इफ़ i बराबर m-1 एंड j बराबर n-1, उसका भी चिंता करने का कोई ज़रूरत नहीं, अपने आप हो जाएगा क्लियर, इट विल गॉट क्लियर्ड। अब उसके बाद रिटर्न क्या कर देना है, विजिटेड ऑफ m-1 n-1, यही कर देना है रिटर्न। सारा चीज़ सही है ना? हाँ सही है। देखते हैं रन करा के। So it's working, you can see. Let's see on all the example test cases we have. So डायजेक्ट्रा का इम्प्लीमेंटेशन है, यहाँ पर डायजेक्ट्रा का एक सिंपल सा सवाल है, बस यही है कि ग्रिड दे दिया है, तो देख लेते हैं। तो इट हैज एक्सेप्टेड, यू कैन सी। इस सवाल को भी देख ले गया, शॉर्टेस्ट पाथ इन ए ग्रिड विथ ऑब्स्टेकल एलिमिनेशन, क्या है ये, इस सवाल को भी चलिए देख लेते हैं। So you are given m cross an integer matrix grid where each cell is either 0 or 1. You can move up, down, left, right from any empty cell in one step. Return the minimum number of steps to walk from the upper left corner 0 0 to lower right corner, and when it's given that you can eliminate at most k obstacle. If it is not possible to reach such walk, return -1. ये थोड़ा सा अच्छा सवाल है। इसका सबमिशन कितना है? 1,86,000। बाप रे, 1,86,000 इससे एक्सेप्टेंस है। तो इससे पिछला वाला ही ठीक था। ये सवाल इसका कितना है? 18,000 सबमिशन। यही सवाल किए अपना लोग अभी। बहुत अच्छा सवाल है। Could you use 01 BFS सर्च और डाइजेक्ट्रा एल्गोरिथम? डाइजेक्ट्रा ही लगा लेंगे यार। तो ठीक है, ये वी हैव डन विद दिस क्वेश्चन, सो वी कैन मूव टू द नेक्स्ट क्वेश्चन वी हैव। सो ये ग्रीडी सेक्शन का सवाल मैंने लिया है कि मैक्स चंक्स टू मेक सॉर्टेड टू। सवाल का नाम है 768 नंबर सवाल है, मैक्स चंक्स टू मेक सॉर्टेड टू। तो यू आर गिवन एन इंटीजर एरे ए आर आर। आपको एक इंटीजर एरे ए आर आर दिया गया है। वी स्प्लिट ए आर आर इंटू सम नंबर ऑफ चंक्स। सो वी कैन split ARR into array ARR into some number of chunks. Sort each chunk after concatenating them. The result should equal to sorted array. Return the largest number of chunks we can make to sort the array. अच्छा, so we split ARR into some number of chunks. So basically तो हम जो है अपने अगले सवाल की ओर we will move towards our next question. The next question is from the greedy section, max chunks to make sorted to. So basically in this question we have given an integer array ARR. So we split ARR into some number of chunks, that is partition, and individually sort each chunk. After concatenating them, the result should be equal to sorted array. So return the largest number of chunks we can make to sort the array. So basically we have given an array ARR. So basically we can partition that array in some parts, and let's call that each parts, let's call them a chunk. Okay, basically you can break this array in some number of sub arrays, and each sub array you can call it as a chunk. So you have some number of chunks after partitioning the array, that is basically some number of sub array after partitioning. So, and every partition, let's say you are sorting, you sort each partition, and after sorting each partition, let's merge them, let's concatenate them in the same order we have, and after that concatenating, the array should be sorted. So this new array after partitioning, sorting and concatenating will become a new array, and that array should be sorted. So they are telling us, they are telling you to find that largest number of chunks we can make to sort the array. Largest number of chunks. We split ARR into some number of chunks, that is partition, and individually sort each chunk after concatenating them. So return largest number of chunks we can make to sort the array. So basically we want to maximize the number of chunks. So as many sub array you can make it. So number of chunks. So basically as we know, if we consider whole array as a single chunk and we can sort them and concatenate them, it will become a sorted array. So no problem in that case. So basically the minimum number of you can say the chunks so that the array becomes sorted is 1. So we want to maximize that number of chunks. So if the array is, let's say, already sorted, then every element can be considered as a chunk, and we can sort every element and every chunk, and it is already sorted, and we can concatenate them, and the new array will become a sorted array. Very simple. So if the array is sorted, the maximum number of chunk is going to be the size of the array, and if the array is let's say if the array is, let's say, in unsorted order, let's say decreasing order, let's say the array is in decreasing order and you want to make it in increasing order, in that case you have to sort the whole array. So the cases we have is very simple. So I will discuss three cases first. Let's say the array is increasing from left to right. It's increasing always, at every point it is increasing. That is, it's monotonic. The array is increasing, or it will remain static, or it will increase. So if the array, if I am plotting the index versus ARRIND, the graph will look like this. If this is the representation of the graph of the array we have, then in that case we don't need to actually concatenate them and sort them. In that case we can consider every element as a chunk, and sort every chunk and concatenate them. The number of chunk in this case is going to be n. So in that case we can actually do it. The number of chunks in this case is going to be n. If the array is already monotonically increasing, you can see monotonic increasing means in some ranges it will remain not increasing, it will remain static. It's not increasing. So that's it. So this is the first case we have. Array is monotonically increasing. Let's talk about the second case we have, that array is not increasing, it's actually equal. Every element of this array is equal. In that case also it is a monotonic increasing. So this case is also a monotonic increasing case. So in this case also you can partition the array into n number of chunks. Every element can be considered as a chunk, and you can concatenate them after sorting them. So in that case the maximum number will be n. Now let's talk about some other cases, that let's say the array is like this. Array is strictly decreasing, the value is decreasing. So if you want to sort it, then you have to consider a single chunk, and sort them. Then only you can sort it. Because let's say if you partition it something like this, that you are considering this part as a one chunk and this part as a other chunk. If you are considering like this, then what will happen? If you sort it, there is some elements in this range which is greater than every element present in this range in the prior chunk. So there is a chunk after the first chunk. There is a chunk whose name is 2, and there is some element in the first chunk which is actually exactly greater than every element present in the chunk 2. So if you sort these two chunks individually and concatenate them, there will be some element in this chunk which will be greater than the elements present in this chunk, and in that case after concatenating, your array can never be a sorted array. So in that case what you have to do, you have to consider the whole array as a single chunk. So there is observation from here. We can simply see that observation, that why can't you consider these two chunks as a separate chunk? Why can't you consider these two chunks as a separate chunk? Here is the observation. We can clearly say, let's the array is decreasing and you consider this part as a single chunk and this part as single chunk. But if you consider like this, you can't actually consider like this, because if you are considering the chunk like this, what will happen? The cases are very simple, that if you are going to sort the first chunk and you are going to sort the second chunk and then concatenate them, as you know the array is strictly decreasing. There is some elements in the chunk 1 which is greater than every element present in the chunk 2. So if you are sorting these two chunks individually and merging them and concatenating them, then what will happen? There will be some element present in this range which is greater than every element present in the range from here to here. So it is not sorted now. After concatenating, it will be not a sorted array. So you can't consider the chunk like this. Very simple. So here is the observation, that why you can't consider the chunk like this. There is a simple observation. There is some element present in the chunk 1 which is greater than every element present in the chunk 2. So this is the observation here, that if I write the observation, if chunk one has some element which is greater than every element in chunk 2. समझ गया ना, ये बात है, आप इसीलिए नहीं ब्रेक कर सकते. This is the reason why you can't break the chunk like this. So let's say if I start breaking the chunk from here, I start iterating that where I can put a chunk, can I put the chunk at this place? I want to find that. So basically every element, the smallest element in this region, there will be element which is the smallest element in this region. That element should be greater than the largest element in this region. If this is the case, then only you can concatenate, you can partition from this index. If the largest element in this region is lesser than or equal to the smallest element in this region, then only you can partition from this place and consider this part as a chunk. So this is the observation from here. So using this observation, very simple observation, we can proceed. And the maximum in a range and maximum in a prefix and suffix, we can store a prefix array, maximum prefix array, and we can store a minimum suffix array. That is from n to any index I, what is the minimum value of the element present? We can consider like this. And from 0 to, let's say, any index I and d, what is the maximum value present in this range? So we can consider like this. We can store the prefix array and suffix array, and we can simply find that from where we can concatenate, and the places where we can partition, we will count in that manner the number of partition. If the number of partition you have placed is, let's say, x number of partition you have done, the number of chunks will become x plus 1. Very simple things we have. If you have x number of partition, then if you have 3 partition, then there will be 4 chunk, 1 2 3 4. So number of partition we can simply count, and that partition is going to be the maximum number of partition we have. So very simple solution we can write for this problem. It was not that much of tough, but there was a good observation. So if you are familiar with that observation, then it will not take lots of time. So if you have never solved the problem like this, so it's little difficult to observe that observation. So I have not solved that much on this observation, but at some time I have thought about this observation. That's why I am able to get it right. Okay, so we have a prefix and suffix now. Let's make a vector of int ref arr dot size, and let's make stuff, and also its size should be equal to arr dot size. After doing these two things, what we can do, very simple thing we can do is from here that we can run a loop for int I equal to, so ref of 0 equal to arr 0. In pref I want to store the maximum now, so for int I equal to 1, I less than arr dot size I plus plus, and what we can write, pref of I is equal to maximum of pref of I minus 1 comma arr I. Very simple things we can do. Now we have stored our maximum in a range, maximum in the prefix. Now we will do for minimum in the suffix. So suff of arr dot size minus 1 is equal to sum of नहीं arr dot size -1. Very simple things we can. Now we can run a loop for int I equal to arr dot size -2, I greater than equal to 0 and I minus. Okay, now the next thing what we can do is nothing but sum of I is equal to maximum of sum of I plus 1 and arr of I. Very simple things we can do. So in this way we can store our prefix and suffix array. After storing the prefix and suffix array, we will iterate from the last for int I equal to arr dot size -1. So and arr dot size -1, I greater than equal to 0 and I minus. And what we will check? We will check that the maximum in the range 0 to I plus 1. The maximum in the range, let's make it greater than 0. So maximum in the range 0 to I plus 1. Maximum in the range 0 to I plus 1. So pref of I plus I minus 1. Pref of I minus 1. If pref of I minus 1 is less than or equal to sum of I. So minimum in the range 0 to I is greater than equal to maximum in the range 0 to I minus 1. Minimum in the range I to n minus 1 is if greater than equal to maximum in the range 0 to I minus 1. If that is the case, then we can partition at this place. So int count equal to 0. Let's have a count is equal to 0. So count plus 1 will be the number of chunks. So return count plus 1. This is going to be the answer we have. So let's see it's working or not. I think it should work most probably. So it's working, you can see. So it's not working on these test cases. We have 4 3 2 1. It should become sorted. It's giving 1 5, but it should give 4. Acha. Minimum in the range is greater than equal to maximum in the range 4. One partition from here, 3 2 1. They are telling 4. It should give 4. It is giving 5. Why it is giving 5? From here partition will be take place. From here partition will be take place. From here partition can be take place. So suffix here I have to store minimum. Now I have stored maximum. Here I have to store minimum. In suffix we want to store minimum. Now it will work. There was a simple error in the code. I wrote a lot that I used to. So it's working. We can submit it. Let's see it works or not. I think it will work. So it worked. So we can move to our next question we have. So let's move to our next question. The next question is from the DP section we have, and the next one from the math section. So I think I want to attempt first the chalkboard jar game. So this is the mathematics problem. I want to attempt first attempt this problem. So let's attempt it. So if I will attempt it, let's read the problem statement we have. So chalkboard jar game. You are given an array of integers. Nums represents the number written on a chalkboard. So you are given an array of integers nums. So basically we have given an integer array nums, and it represents the number written on a chalk board. So there is a board on which you can write using chalk. That's why the board is named as chalkboard. So you have given some number, there is some number written on that board, and that number you have given in the form of an integer array nums. So Alice and Bob take turns erasing exactly one number from the chalkboard. So Alice and Bob take turns erasing exactly one number from the chalkboard, with Alice starting first. If erasing number causes the bitwise JOR of all the elements of the chalkboard to become 0, then the player loses. The bitwise. So very good. So Alice and Bob are playing a game with the chalkboard. So Alice and Bob take turns erasing exactly one number from the chalkboard. So the player whose turn is at the time can erase some number from the chalkboard, some number present on the chalkboard, with Alice starting first. So Alice starts first. He will first erase a number present on the chalkboard. If erasing a number causes the bitwise JOR of all the elements of the chalkboard to become 0, then that player loses. The bitwise JOR of one element is that element itself, and the bitwise JOR of no elements is 0. So also, if any player starts their turn with the bitwise JOR of all the elements of the chalkboard equal to 0, then that player wins. Okay. So the player who got the turn when JOR of all the elements present on the board is 0 wins the game. So basically, the player who erases a number, and due to that the JOR becomes 0, that player is going to lose. Okay. So initially, in the initial cases, if let's say the JOR of in the initial case, let's say the JOR of all the elements is exactly 0 when the game starts. In that case, Alice will have that turn, and he found that all the JOR is 0. In that case, he will tell that he is going to win the game. So this is the first case. And when the game proceed at any stage, let's say the Alice has its turn, and he used to erase one of the elements from the board, and due to that remaining elements JOR gives you a value 0. In that case, the player who erases that time is going to lose the game. So basically, they both are playing optimally, and we have to find return true if and only if Alice wins the game, assuming both players play optimally. So return true if Alice is going to win the game, and otherwise return false if Alice is not going to win the game. Let's see the constant we have. nums.length is 100, and 2 की power 16 bit number we have given. So it's in the range of integer range. So integer range number are present in the game. So what is the cases we have? How the player will think? Let's say at the current time my turn is, let's say at the currently this is the game situation. So how can you define the state of a game? Always, if this type of game is present, there is always a state of game. A state of game means game is at some state. Always there the game will be at some stage. So in this the game we are talking about, in this game the stage is like that. The stage is like that. A stage is defined like this. You can say the stage is defined like this. So how you can define the stage of the game? The stage of the game. How we can define the stage of the game? A stage of the game is very simple. That some number of elements will be present and some got erased. And at the moment, the turn will be of either player P1, that is Alice, or the turn will be of Bob. So this is the two situation of the game. A state of the game is defined by the elements present in the game, and also one more thing, elements present in the game and whose players has their turn. So these two things define the state of the game. Okay, so this is so what is the initial stage of game? Initial stage of the game is Alice, the turn is of the Alice, and the whole array nums is present. So this is the initial stage of the game. So if the game starts from this stage, who is going to win? Who is going to win? This is the problem we are asking about. तो कौन जीतने वाला है अगर गेम स्टार्ट होता है इस स्टेज से? That is initial stage we have defined. that elements present will be the integer array nums, and the third is of the Alice. So we are clear with these points. So now we can proceed for the further points. So how can we move forward in the game? How we can how we can proceed further in this game? हम जो है इस गेम में फर्दर आगे कैसे प्रोसीड कर सकते हैं? How we can proceed? अच्छा, so let's say when the game starts, let's say at any stage of the game, Alice has their turn. So Alice wants that he wants to play the game in such a manner. That if we remove some element, it should not become 0. First thing, and he removes the element such that after removing some number of elements will present, and that will not give jar 0. But after that, if Alice is going to remove any element, jar should become 0. That's the main aim of the game. And this is the one way of telling the things. And another way people can tell that whenever I am playing the game, I will think that after erasing some element by me, there will be some remaining element, and from that stage it should take odd number of moves to remove to make it jar 0. Odd number of moves. Likewise we can think of, but so one solution everyone has in their mind, that is very simple thing that he was thinking of. Everyone have there in mind that he was thinking of something DP transition, that we will consider all the choice. Game theory like problem in the DP min max DP, there will be a stone going problem. So many of us used to think in that direction, but that direction is not going to work here. But we have to do something with the mask, bet mask, if it is going to work. So how we can move? How the game can be considered as? गेम को आप कैसे देख सकते हैं? चॉक बोर्ड जॉर गेम